In the last class, we have discussed about the logistic regression and also evaluation parameters, evaluation metric. Now in today's class, we are going to see the project on the logistic regression, how to implement the logistic regression, and also calculate all the performance metrics. Whatever we have discussed for the classification performance metrics, we are going to do each and everything. Apart from that, along with that, we are going to see which one is more important. Like with respect to TPR, FPR, sensitivity, specificity, precision, recall, based on all these things, we are going to understand in today's class. Now, logistic regression. So what is meant by logistic regression means this is also one of the classification algorithm. Basically, it is a classification algorithm where it will predict the output of probability. It is going to predict the probability for that particular record. What is the probability of being that particular class, right? So out of which how it is going to work means first it is going to apply the concept of linear regression, that is y is equal to beta naught plus beta 1 x, and whatever the y hat we have got, this will be applied on the sigmoid function and it will calculate the probability by applying 1 divided by 1 plus e to the power of minus y hat. Y hat is nothing but whatever you have got here, the same thing, that is nothing but 1 plus e to the power of minus beta naught plus beta 1 x. If it is having only one x variable and one y variable, this is that scenario. For example, I'm having 2 or 3, that is x1, x2, x3. 3 input variables are there and y is there, means p is equal to 1 divided by 1 plus e to the power of minus beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. So it is just calculating the probability. The output is going to be the probability. The logistic regression predicts the output called as probability, and based on the probability, we are going to classify whether it belongs to that class or this class. So if it is a binary class, so we are having only 2 classes in the output variable. So based on the whatever the probability value we have got, based on the probability value, we are going to decide based on the probability and selecting the threshold value. By selecting the threshold value, we'll classify that particular record belongs to either of the class, either 0 class or 1 class, right? By default, logistic regression considers the threshold of 0.5. And if you want to change the threshold value, you can change the threshold value also, right? Implementation of logistic regression. So first I'm going to import NumPy as NP, Pandas as PD, Matplotlib, and Cburn, the same 4 libraries which we have discussed. In today's class, I'm going to start a new library called as warnings. So what is this warnings means? If, for example, we are going to get something and we'll get some kind of down pink color, right? Which it is showing, shows some kind of warnings. So that warnings, not errors. Warnings which will be in terms of pink color, that will be ignored. So what I'm going to do is just I'm going to ignore so that it will not be printed. Okay, wherever the warnings are there, it will not be printed. So just to ignore the warnings, I'm writing import warnings and simple filter ignore. Ignore means it will ignore that warnings. It will not show us. If any warnings are there, it will not show us. If you don't write this one, it will show the warnings, whatever the warnings are there, right? Now, first what I'm going to do is first I'm going to take the diabetic data set. So now this first any project, okay, any project has to be implemented using these 6 steps only. Any project has to be implemented using the 6 steps, right? Using the 6 steps. So what are the 6 steps means? The first one is business understanding, data preparation or data pre-processing, that is cleaning and transforming the data, encoding, all these things has to be done here. And you have to apply the modeling. Within the model, you have to do the hyperparameter tuning and you have to identify which is the best model, and evaluation, and finally whatever the inferences you have done, you have to present that one. So this is the project which you have to implement as a data scientist. Now whenever I'm explaining the logistic regression, if I'm applying on the ML algorithm 1, okay, discuss only ML algorithm 1. Don't think of the ML algorithm 2. There is no algorithm 2 is not available. Assume only one algorithm is there for this data set. You have to implement one algorithm. Within that only, whatever you can do the best, try. Don't go to another algorithm. Within the algorithm only, whatever you can do the best one, try that one. Then it is called as one project. Implementing all the algorithms on the same data set is called as capstone project. The difference between a capstone project versus a normal project is you are working on a single algorithm that whatever the maximum you can do for this algorithm, identifying the best parameters or doing the best within the one algorithm, machine learning algorithm one, that is logistic regression, identifying the best thing is called as a project. And if you are applying with respect to different algorithms for the same data set, you are applying all the algorithms and identifying the best final model and creating the pipelines and all these things is called as capstone project. So now itself, if you think of the capstone project, sir, if this is the thing and I have to implement this one or that one, and now itself, if you think like that, yourself, it make as complicated. So as of now, you have to understand we are implementing only one algorithm. Don't think of second algorithm. When I'm explaining second algorithm, think about only that algorithm. Don't think about the first algorithm or third algorithm. When I'm explaining the third one, think about only the third one. Don't think about the first one or second one, or don't think about the fourth one. When we are focusing on single algorithm, focus only on that. Once every algorithm of classification, total 10 algorithms are there. Okay, 10 algorithms are there. 10 ML algorithms are there related to classification. 10 are there. Once I complete all the 10, I will show you the capstone project. That is implementing all of them on a single data set. I will show you. Okay. So how to implement that one, that I will show at the end. After doing all the things. First, before to that, assume there is only one algorithm. Within that only, whatever you can do, the best you have to try. For each and every project. Right? Now here, what I'm going to do is, I'm going to work on the diabetic data set. Now, diabetic data set where the output variable is, we have to predict whether the person will have the diabetic or non-diabetic. Yes or no. This is the data set. Whether the person will get a diabetic. For example, this is the head function only. Just head function means first 5 records only printing. But actually, how many records are there? Means total 768 records are there. After analyzing all these 768 records, you have to predict for a person. For example, I'm having a value of 4 and 144 and 79. And 36, 0, insulin is equal to 0, BMI of 27, and this function of 3.6 and age of 36. And what is the expected outcome? For this one, you have to predict. Right? What is the business problem here? Miss, the business problem is identify the relation between the input variables versus output variable. And identify whether the person will get a diabetic or not based on the input features. Is the problem statement. This is the problem statement, right? Identify whether the person will get a diabetic or not. He is a diabetic patient or not, right? Based on the input features, whatever this is, write in your notes these values. Otherwise, I will delete now. I will forget. Please, can anyone, at least one person write? No need everyone, just one person if you write, please. 4, 144, 79, 36, 0, 27, 0.36, 36. We have to predict whether the person will get a diabetic or not. And if you predict, with what accuracy you are predicting that one. Okay, for example, if you say that it is not a diabetic, no, 0, then what is the accuracy? If you are saying 1 miss, what is the accuracy? Some accuracy will be there, right? That. So here the business problem is whether the person has diabetic or not, yes or no. Now here I'm having total 768 rows are there and 9 columns I'm having. Now first I'm going to do the exploratory data analysis and I'm checking whether this is a binary classification or multi-classification. So in the output variable, how many unique values are there? First I want to check that one. I'm having only 2 classes, either 1 class or 0 class. Only 2 classes are there. It is called as a binary classification problem. So I'm going to check the unique values of the output variable. Okay, dot unique gives you the unique values and output variable outcome. Output variable is last one, which is the output variable. This is the output variable. Now, here I'm going to apply the describe function and I'm going to check whether what is the minimum value of glucose level is there to maximum value and what is the blood pressure generally out of these 768 patient records, whatever the records they have given. Within that, what is the minimum value? What is the maximum value? What is the BMI of minimum to maximum? What is the age minimum to maximum? So in this particular data set, they have collected only the ages of 21 to maximum of 81. They have not collected less than 21 or more than 81. So this particular data set was given as like this. Next, I'm going to do the heat map. So whatever that you want, you can do. The EDA, data cleaning, I have explained. So you have to implement and you have to identify the relations and you have to do the EDA separately. I'm not going to explain for each and every project EDA. If I start explaining for each and every project EDA, almost every time will be completed there only. Most of the time will be completed there only. So in 1.5 hour session, how much time I have to spend on the theory and how much time I have to spend on the practicality? Within this practical, should I focus on the machine learning algorithm or should I focus on already completed EDA and cleaning part? Which one I have to focus? Every time I'm focused, for example, theory part was done for 30 minutes or 40 minutes. I'm demanding 50 minutes. I'm working on the practicality. Within this, again, repeating the same thing EDA, repeating the same thing data cleaning, then what is the use? Focus on the ML algorithm. Because this is the first time you are saying this. Already you have told multiple times. Now, no need to explain this one. So that is the reason I have taken separately EDA and data cleaning. If I want to explain in the project only, then why I have to take separate class for that? I can include here only. Why to spend separate time for data cleaning and data wrangling or all these things? Directly like in the project only I can implement, right? So these data cleaning and EDA, whatever it is there, you do that one, right? So here I'm checking with respect to any missing values are there. So there is no missing values and encoding. So in my data set, there is nothing. There is no one variable is also not a categorical variable. So nothing object is available. All of them are int 64 or float 64. None of them is object. Object is not there. Object means discrete categorical. If discrete categorical is there, we have to do the encoding. Since the discrete categorical is not there, no need of encoding also, right? So in my data set, I no need to do any kind of encoding. Directly I'm moving on the X and Y. Means I'm applying the baseline model. So basic of compulsory things, data cleaning inside the data cleaning, missing values is compulsory. Next one is in the data wrangling, encoding is compulsory. Whichever is compulsory, that I am doing. Additional things after the class you have to do. So after the class, what you have to do and how you have to do practice everything, I'll explain. Okay. Now, X and Y, I'm considering the X variable and Y variable. Apart from outcome, everything are X variables and outcome variable is the Y variable. Now, train test split. I'm applying the train test split where test size of 0.2, random state of 9 I have considered. Now, I'm going to do the modeling. Modeling with logistic regression. This is the base model for classification algorithms. How we are having the linear regression for regression algorithms. This is the base model for classification algorithms. Okay. So applying the baseline model, that is logistic regression with respect to from sklearn.linear model, import logistic regression. And I'm going to save it as a model called as log model. And I'm fitting on the X train, Y train. Modeling is every time 3 steps. One is import, second one is save, third one is fit on the X train, Y train. Every time it is fixed. So the same 3 lines I have written. And next prediction. Model.predict on X train, model.predict on the X test. The same thing. Whatever we have done in the regression algorithm, same to same. Next, here I'm going to calculate the accuracies. For regression algorithms, we have to calculate the R-square values. That is for regression algorithms, where the output is continuous. For that, we have to apply R-squares. Logistic regression is a classification algorithm, not a regression algorithm. It is a classification algorithms. For classification algorithms, we are going to work on the accuracy. Okay. So here I'm going to calculate the from sklearn.metrics, import the accuracy score. I'm going to import the accuracy score. Inside the accuracy score, I'm going to give you the Y train, that is original value along with the predicted values. Similarly, accuracy score of test data, test original data, predicted data. Same as whatever we have done for the in the regression, same as R-square. Instead of R-square, here just you are considering the accuracy score. The only difference is that one. And it is calculating 79% of the train accuracy, test accuracy of 76%. Now, cross-validation score. You are going to check the cross-validation score where you are going to give the model X data, Y data, CV is equal to 5. And cross-validation you are going to get as 76%, which is almost close to your test accuracy. So from this one, we are going to say it is neither overfitted or underfitted. From this, we can conclude that this model is a good model. But whether it satisfies the business requirement or not, that is secondary. But it is a good model. For example, the client has given me to predict the answer with 80%. This model is not sufficient. Then it is not sufficient. We have to do modifications. For example, the client has asked with 75% accuracy is sufficient. Submit. Directly you can submit. Right? Now, once we check this train and test accuracy along with the cross validation, now next we are going to do the confusion matrix. We are going to form the confusion matrix, and in the confusion matrix we are having this one as this side we are having the predicted values, and this side we are having the actual values. Right? So actual 0, predicted 0, 1, 0 and 1, 0 and 1. So you are having a confusion matrix. Always the confusion matrix predict on this side, actual is on this side. And 0 and 1, 0 and 1. Right? So now here you are having with 85, 15, 21 and 33. So nothing but 85 plus 33 divided by 21 plus 15 plus 85 plus 33 is your accuracy, which you have got is the same answer which you have got is 76.62. If you calculate, it is same as 76.62. For test data, I am calculating the confusion matrix. I told you already how to formulate the confusion matrix. From 2 days, we have discussed the same. Right? Next one is classification report. So for classification report, I'm going to give the original test data and predicted test data so that it is going to calculate the precision of 0 and precision of 1. Similarly, recall of 0, recall of 1, F1 score of 0, F1 score of 1, and overall average F1 score is nothing but your test accuracy. Test accuracy is nothing but average F1 score. Average F1 score is nothing but test accuracy, which is 77%. Okay. Now, next AUC. How to formulate the AUC? That is from sklearn.metric, import plot underscore ROC underscore curve. And inside this, you have to give the model name and the data, X data, Y data. Then if you ask this one, it is going to plot the ROC curve. Okay, this is the ROC curve. ROC is nothing but for different threshold settings, TPR versus FPR, true positive rate versus false positive rate. TPR versus FPR, the ROC curve, you are going to get a ROC curve. And within the ROC curve, what is the area under the curve is 0.81. AUC value is 0.81. This is the model. Now, sir, now the question is, if they have asked you to identify the accuracy, you have to identify only the accuracy. You have to focus only on the accuracy. For example, my requirement is accuracy of 70% is my requirement. Assume case number 1. Case 1, the client requirement is accuracy of 70%. Satisfied? It is 70%. At the same time, it should not be overfitted or underfitted. For example, you have got with respect to this 76, but you have got 54 here, train accuracy 54 and test accuracy of 76. You can't submit. 70% with no overfitting and underfitting. 70% with no underfitting and overfitting, or at the same time, cross validation score should be equal to your test score. So it is satisfied. Since it is satisfied, up to here, if it is completed, just you can share the model. This is your final model. Whatever the model is there, this is the model name. This model name you have to save and you have to submit to the deployment team. This is the model name. Right? So just import the job lib and load that one as the model name. Log model you have to load. Okay, case number 2. My requirement is not accuracy. Case number 2 is false negatives. False negatives, or for this data set, first let us apply prediction side, predict and actual. What is 0 and what is 1? 0 is nothing but no, and 1 is nothing but yes. Sir, how you have decided? Because 0 first comes, n will come first. After that, y will come. When they in the actual data, they have to give yes and no's. but they have encoded that one also and they have provided the data. So directly they have only encoded. When they have encoded, automatically S will become as 1 because alphabetical order wise. Right? Now here I'm having with respect to no and yes. Actually also no and yes. Now, actually the person is not having no sugar. Means that is diabetic. He is not having any kind of diabetic. And you also predicted he is not having diabetic. Okay, good. And the person is actually having the diabetic and you also predicted he is having the diabetic. Again, good. These both are good only. No problem. Now, out of these two, which is dangerous? For example, the person is not having any kind of diabetic. There is no diabetic. Okay, actually the person has no diabetic. But you predicted as diabetic. Now what happens? If you are predicted wrongly, then what happens? You will give with respect to the medicines related to diabetic medicines. Now he will take the diabetic medicines. Automatically what happens? Glucose level will be dropped suddenly. There is a probability that glucose levels drops and he may fall. Something happens. Suddenly glucose should not be very high. It should not be low. It should be normal. In the normal level only it should be there. So now actually the person is having the diabetic. Actually is diabetic and you predicted as no. Now what happens? He will have with high sugar levels. Automatically there is a probability that he may die. Anything can happen, right? In this case, in this particular example, which is important, this one or this one? Both of them are important. When both of them are important, accuracy plays the key role. For example, only this one is important for you. Assume this is the only important for you. Then in that case, you are going to focus on the false negatives or false positives or false positive rate or false negative rate or specificity or sensitivity recall or whatever it is. So based on the problem, we have to identify which part we have to focus more. In this case, you tell me which one I have to focus. Both the things I have to focus or any one or only special one I have to focus. Both the things you have to focus. Means both of them should be wrong. Both of them should be low. Whatever the wrong things you are doing should be low. Both of them should be low. Means misclassification rate should be overall should be low. Automatically accuracy should be high. Your requirement is accuracy. Now you have to create a model for this data set. You have to try a model which gives the maximum accuracy. You have to work for this data set which gives the maximum accuracy. You should not focus neither true positive rate or false positive rate or true negative rate, nothing like this. You should not focus on the recall or precision or F1 score. Here in this case, you have to focus on the accuracy for this data set. So like that, we are going to decide which one is more important. When accuracy is important, automatically AUC is also equally important. AUC also tells about for every threshold, the higher the AUC, the better the model. No, sir, for me, precision only required. Precision only required means you have to see the precision of 0. You want this one only high value. So for this model, what is the precision? 0.8. You write that one. Logistic regression has given the precision of 0.8. You try with another algorithm, ML algorithm 2. For that, 0.7. ML algorithm 3, 0.4. ML algorithm 4, 0.9. Now, out of all of them, which one is the best one? This one is the best one. You have to decide based on this, irrespective of accuracy. Now, you should not focus on the accuracy. Accuracies are used to check whether overfitted or underfitted only. You should focus only on the precision value. That whether you have to decide on the precision app, decide on the recall app, that will be decided based on the problem or the client requirement. So how we can know that one is when we are starting the project, before to the project only, when we are understanding the business problem, the first step of business problem only, at that time only we'll decide for which one we are going to work. Based on that, we are going to work in the further. Is that clear? Got the point? So this is a diabetic prediction data set. Done? Getting voice issue. Abhay says that voice is not clear. Can you please confirm is my voice is clear or not? Close that. It is clear, right? Done. Topic also clear? So you are implementing, see this one. So yesterday's, whatever the evaluation metrics are there, out of which I have shown you the accuracy, how to calculate the accuracy, no manual calculation. Just import accuracy score and give the input values. No need to do manually, nothing as manual. But in the interview, they will ask you the multiple questions. In the interview, they'll ask with respect to take any values of your choice. Can you calculate the pressure value? They'll give the y and y hat values like this: 0, 1, 0, 1, 1, 1, 0, 1, 111. They'll give like this. And can you calculate the pressure of one, please? They'll ask. Sir, I don't know how to calculate, sir. I know only import classification report. Inside that classification report, I know how to see these values only, miss. You will be rejected. You don't know what is the meaning of pressure. You don't know how to calculate pressure. You know the only thing is import. I know only Python code, sir. I know only to import classification report and fill the values, miss. They'll simply reject in the companies. We should understand what is meant by precision and what is the importance of precision and where it is going to be useful. And which scenarios we are going to work on the precision and in which scenarios we are going to work on the recall. And in which scenarios we are going to focus on the accuracy. That should be very clear. This is one of the example. Now in the one more example later, tomorrow, sorry, not tomorrow, today only. Okay. So we are going to work on the one more algorithm, KNN algorithm. Next algorithm is KNN. In that KNN, I'm going to take a different data set. For that different data set, we have to identify which is the best one and how to do the best. When we are working exclusively on KNN, focus only on the KNN. Forget about the logistic. Assume there is no logistic. Within the logistic, I have done with the maximum within the logistic. In the class, what I have shown you now, within the logistic, I have applied the logistic regression and I have got the train accuracy of 79%, test accuracy of 76%, CV value of 76%, 76.82, 76.62. 76.62 means almost equal to 77 and this one also is equal to 77. And AUC, whatever the AUC value is equal to 0.81. From these both observations, I'm going to say whether it is overfitted or underfitted means it is a good. Based on these two, that is test accuracy and CV value, again it is a good. So finally it is a good model. So I have got like this. Now, what is your work after the class? After the class, you have to revise the same thing, whatever we have done in the class. First, you have to revise. After revision, now you have to do the betterization. Now, betterization in terms of two ways. How to do the better model within the logistic. Don't apply the different model. Within the logistic, I want better. How to get the better? Option number one is called as hyperparameter tuning. What are the various hyperparameters are available for this particular algorithm? There is no hyperparameter tuning is available for logistic regression. For logistic regression, like similar kind of linear regression, there is no hyperparameter tuning. What is the second option? Second option is future engineering. That is, whatever the data cleaning, I have not cleaned the outliers. I have not transformed the data. I have not done anything. There you do the modifications and get the better model. Your work is that one. In order to get the better model within the logistic only, don't go with the other algorithm. Within the logistic, try whatever you can do. This one is mine. Now you have to do better than this. For example, you have got train accuracy of 72%, test accuracy of 82%. What I have to do with this one? There is no use. Simply strike off. Because it is overfitted problem. I want the better model, which is a good one only, not the worst models. So, for example, test accuracy 77 I have got now. Your test accuracy you have got 79. Train accuracy you have got 81. Then okay. Then automatically this is basically a good model. Along with that, this is improved. Simultaneously, it is improved. I want in that way, not with respect to either overfitting or underfitting problem. Sir, I have tried, sir, and I have got 86 accuracy of test accuracy, train accuracy, but 80 only. Worst. No use. Though you have got test accuracy 100% also, there is no use. There is one more model in the decision tree. There is one more model algorithm called as decision tree. Decision tree will always gives you the train accuracy 100%. Always. Whatever the data you provide. Any data. Worst data, good data. Whatever the data you provide, it will give always train accuracy 100%. Train. Test accuracy, maybe 70, maybe 80, maybe 90, anything. Anything can be possible. Test accuracy. Train accuracy is always 100. Test accuracy, for example, you have got 90. It is having the overfitting problem. That is the reason in the real time in the industry, we not use the default decision tree we not use. We'll do the hyperparameter tuning for the decision tree. Decision tree is the one of the most important algorithm because it gives the train accuracy of 100%, but it is having the problem of overfitting problem. It is a basically good one only. For example, in this class, one student is there. He is talented only, but he himself will confuse because by taking the complex examples. Now itself he'll think that, sir, if I do this one, what happens, sir? Now itself he'll think everything. Alright, just now I have explained logistic regression. You have to practice. First you have to understand clearly. Later you have to apply. No, now itself he will apply. He will confuse himself. He will only make complexity and he will only get everything confused. Basically, he is a talented only. Due to his over excitement or over things, he is getting confused. That is called as overfitting problem. Now, we can't ignore that type of student. We have to change that student. Array, don't do like that. Do in this way. Automatically, everything one step after one step. If you practice like this, automatically everything will be clear. You will not get confused. If you follow the pattern miss, you will not confuse. If you don't follow the pattern miss, automatically you will confuse. That pattern is nothing but hyperparameter tuning. So basically, decision tree is a very good model. But the problem is overfitting problem is there. So what we are going to do is hyperparameter tuning will be applied. And based on this only advanced algorithms are designed. Assemble algorithms, boosting algorithms, so many algorithms are designed based on this. In the industry, 90% of the solutions will get based on this one only. One of the most important one, which we are going to discuss in the day after tomorrow's class. Don't miss that. Okay. Don't miss day after tomorrow's class. In entire data science, day after tomorrow's class is the most important class. Okay. If you understand day after tomorrow's class, Saturday class will be easy, Monday class will be easy, Tuesday class will be easy. Automatically I have told you, okay, Saturday there is a class, right? Monday I am on leave, right? So I'm going to compensate that one this Saturday. Okay, plan accordingly. If I explain Friday decision tree only, next day class of random forest will be easy. Tree is clear means forest will be clear because multiple trees only, na? Tree is clear means forest will be clear. You are thinking joke, na? Really also it is same. Random forest means nothing but forest means multiple trees. Multiple decision trees is called as random forest model. Concept will be very simple. If you understand this one, this is 5 minutes. 5 minutes algorithm. If you understand this one. If you don't understand this, this is the most complicated one. Right? So just a link is there. Everything are connected to each other. If you come in the pattern miss, everything will be easy. Many of the students, just due to some over excitement only, they'll confuse themselves by applying different things in between only. Actually, we have to do the Kaggle computation once we complete the machine learning. Now itself, one student will come and they'll show that sir, in the Kaggle one data set is available, I want to do. He himself will confuse. Then we can't do anything. One person will say KNN, one of the dead easiest algorithm. Out of entire ML algorithms, easiest algorithm. And not useful algorithm. Okay, because this is, okay, you have to tell me at the end why reason behind that. Okay. Now, KNN, the full form of KNN is K nearest neighbors. That is the algorithm name. K nearest neighbors. right? K value unknown, we don't know. That we have to do the hyperparameter tuning for the K only. We don't know for the given data set which is the best K value, we don't know. That only we have to do the hyperparameter. If the K value is fixed 10 means this is called as 10NN algorithm. If the K value is already fixed with 5 means 5NN algorithm. So it is not fixed, unknown parameter, which we have to do the hyperparameter tuning for the K. Now, K nearest neighbors. K nearest neighbors means it is identifying the nearest neighbors, and based on that, it is going to work. So now, here, how it is going to work means, for example, before KNN neighbor, I'm having, let us take a data set where I'm having two variables x1 and x2 and y. Okay, two variables I'm having x1, x2 and y variable either yes or no, something. Output variable is categorical. Now I'm going to apply the scatter plot between x1 and x2 because x1 is continuous, x2 is also continuous. For continuous variable only we can apply the scatter plot. For discrete variable we can't apply the scatter plot. So both of them are continuous and output variable is discrete categorical variable. Now what I'm going to do is I'm just applying the scatter plot, and in the scatter plot I'm going to write hue. There is an option hue is equal to y value. I'm going to give the y value as the hue and I'm separating. Now I'm having the data set like this. Now for a particular value, some value is there, some value x. This is the data point. Whether this belongs to red category or green category means it will identify for this particular thing, it will identify the nearest neighbors. The nearest neighbors. This one is the nearest. Like this, it will identify the nearest one. How many nearest neighbors it has to identify? That is the K value. For example, K is equal to 5 I have given. So it is applying the 5 nearest neighbors. For this particular data point, it will identify the 5 nearest neighbors. This is the first one, second one, third one, fourth one, fifth one. 5 nearest neighbors it has identified. Out of these 5 nearest neighbors, how many of them are red and how many of them are green? 3 are red and 2 are green. So now this one is also a red one only. Automatically it will be converted to red one. Nearest neighbors are red now, so automatically it is red. That's it. Algorithm completed. Right? So just it identifies the nearest neighbors, and based on that, it will apply the mode. It will apply the mode, which class is having the more category, which category is having the more number of data points, it will convert to that category. Now, what are the steps involved in this means? First, we have to choose the K is equal, some neighbors. K is equal to some value we have to give initially. Otherwise, it will not start. K can be 1, 2, 3, anything. Whatever you want, you can do. K is equal, some K value you have to give. Based on the K value, it is going to identify the nearest neighbors according to the Euclidean distance. Just it is going to apply the Euclidean distance formula. And from that, after among these K neighbors, it is going to count the number of data points in each category. 2 categories are there means for 2 categories, how many data points are there? For each of them, how many points are there? Earlier 3 are red and 2 are green. After that, it is assigned the new data point to the category where the counted with most neighbors, where the more neighbors are there. And finally, your model is ready. Right? So please write these steps in your notes. Each step you write in your notes, I'll explain with a clearly one by one, step by step. Done. Now, let us start step by step. Let us start the step by step, one by one. First, here, first I have to choose the n neighbors. Choice is yours. Anything you can choose as per your choice. Here I am choosing with respect to k is equal to 5. Generally, the k value will be the odd number. Generally, k value will be the odd number. Why odd number? Because if k is equal to 4 is there and two categories from here and two or both are same miss, then it is going to be a problem. That is the reason generally k will be the odd number. No sir, k is equal to 4. Then what happens? Exactly. Then in that case, what happens means it is going to check the sum of the distances. The sum of the distances of these two and sum of the distances of these two, and which distance is low, that one it is going to identify. Okay. Now, this is one point number 1. This point is with respect to this x value and this y value. Point is x1, y1. Okay. Let us assume this point is 1 and this point is 2. Point number 1, 2. There is one more point. This is one more point, which is x2 and y2. Let us take this value of x as 4 and this value of x as 6 something. Okay, 4, 6. This value is 4, 6. This value is 1, 2. Okay, I am having x and y. First record is having 1 and 2. Second record is having 4 and 6. 2 data points only is there. Only 2 records are there, 2 data points, and these are the 2. Now, between these 2 data points, I have to calculate the distance formula. Distance. How I can calculate the distance means option number 1. From here to here, first I will make a horizontal line. Now, what is the distance of this one? That is nothing but x2 minus x1, which is a distance of 3. x2 minus x1. Whether it is a positive distance or negative distance. Negative, for example, 4 minus 1 is there. Negative distance means direction is opposite. Distance value cannot be negative, right? Direction is negative. Similarly, x2 minus x1. So what I'm going to do is I'm going to apply the mod because distance cannot be negative. For example, let us take initial value is this one. You are coming in the backward direction. 4 and 1, the distance cannot be with respect negative. So I'm going to apply the mod. Mod of x2 minus x1. Now this point is, what is this point is called as? x2 comma y1. y1 is same, right? y1 is not going to change. Y-axis is not going to change. So this distance is just of x2 minus x1 is the distance formula. Okay. x2 minus x1, just applying the mod. Now, second one is from here to here, I am going to draw a horizontal line, which is now this time y is common. Y value is common. X value is common. Y is changing. That is mod of y2 minus y1. Now, distance is equal to overall the distance is equal to mod of x2 minus x1 plus y2 minus y1. So from here to here the distance and from here to here the distance. So finally overall the distance is this one. This is called as Manhattan distance. Manhattan has identified this one. So from here to here, if any person wants to travel, means first he has to travel a straight road like this. From here to here again 1. So just he has taken 2 straight lines by using the first one as x by changing in the x, second one by changing in the y. This is called as Manhattan distance. Right? Now, so Manhattan told like this. Now second person has told with respect to Euclidean. Next person is Euclidean. And Euclidean is also a scientist name only. And he has told that no need to travel like this directly from here to here. There is a shortcut. by applying the Pythagoras theorem. Let us assume this is A and this is B. This is square root of A square plus B square. Nothing but D is equal to square root of A square, that is x2 minus x1 whole square plus y2 minus y1 whole square. This was given by the Euclidean. Euclidean has told shortest distance because this is forming anyways 90 degrees. Na? So whenever it is forming a 90 degrees right angle triangle, we can apply the Pythagoras theorem. Euclidean has given this one. So it is called as Euclidean distance. This is called as Manhattan distance. Euclidean distance is the shortest distance. Now, these are the two different distance formulas. If you want, you can write in the notes. Okay. Option number 1 is this one. Option number 2 is one is Manhattan distance, one is Euclidean distance. Euclidean distance is called as shortest distance. Generally, we'll go with the Euclidean because it is a shortest one, shortest route. Distance is clear because this point is 1, 4 point. This point is 3, 4. This point is 4, 6. Now in this case, what is changing? X value only changes. Y value remains constant. Y is not changing. Only X is changing. That too from starting point of 4, 2. And this is 4, okay, done. 4, 2. So X value changes from 1 to 4, but Y value remains with respect to the same. 2 will be remain same. Only the X value from initial 1 to 4, it is going to change. So the distance is just x2 minus x1. That is distance, that is starting point of 1 and ending point is 4 means the difference is 4 minus 1, which is 3. Similarly here, 4 and 4 is there. X is same. Only Y is changing. That is 6 minus 2. Right? Is that clear? Now, this is Euclidean distance and Manhattan distance we are having. Now, whatever the Manhattan and Euclidean distance is there, this is one way to calculate the distances. That is Euclidean distance and Manhattan distance is one way. Now, another way. Now, one student will ask me, sir, why we can't do like this? This is also distance only, na? This is also distance only, na? Why we can't do like this? Anything, if you are interested, you can create your own program. Whatever you are interested, you can create your own program for that. Standard ones are Manhattan and Euclidean. These are the two standard ones. Apart from that, you can create as per your choice. And whatever you have created, that one you can create the def function and write the program as per your choice and give that one as the input value. And according to that one, it will calculate. Okay. Now, this distance, whatever the Manhattan or Euclidean distance we are having, based on the distance formula, we are going to calculate. Now, here, first step number 1 is choose the number of k neighbors. I am using the 5. For this data point, this is the test data. For this one, it is identifying the 5 nearest data points. First, assume this is one of the data point. For this data point, first it will calculate the distance formula of this record. It will calculate the distance of this record, 2. It will calculate the distance of this record, 3. It will calculate the distance of 4, 5, 6, 7, 8. So 8 records are there with the green means 8 distances it is going to calculate. Similarly, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 records with respect to red, 8 records with green. Total 18 distances it is going to calculate. After calculating 18 distances, based on the Euclidean distance. So now this is the point and this is the point. It is going to calculate as per the Euclidean distance. Similarly, for this one and this one, it is going to apply the Euclidean distance formula. For this one and this one, it is going to apply the Euclidean distance formula. For this one and this one, it will apply the Euclidean distance formula. Like this, it is going to calculate all the 18 distances by applying the Euclidean distance formula. Once it is applying the Euclidean distance among the k neighbors, once it is done, 18 distances are calculated. From this data point, all the 18 distances are calculated. After calculating all the 18 distances, now from this, it is going to sort. It is going to sort and it is identifying the least 5 one. Least 5. Which are the least 5 distances are there within that. And so total 18 distances are there, out of which these are the 5 least. After that, among the five neighbors, count the number of data points in the each category. That is 3 here, 2 here. And after that, it will identify with respect, assign the new data point to the category where you have counted the most neighbors. That is red category. In this way, the algorithm works. Now, assume that the same thing for this data set, instead of considering k is equal to 5, I am considering only k is equal to 2 or k is equal to 1. Let us start with 1. Minimum 1 is required, right? So for 1, it will calculate again 18 distances. Again 18 distances. Here, since it is a small data set, for you it is very clear, visible. It is, this one is the latest, very close to that one. It is visible. If you take the data set like this, the data set, in the data set without scatter plot, how we can calculate that one? So the machine is going to calculate based on the distance formula. So it will apply the distance formula and based on the distances for each of them, 18 records it will calculate. For example, 10,000 records are there. 1 lakh records are there. 1 lakh distances it will calculate. 20 lakh records are there. 20 lakh distances it will calculate. Okay. So how many records are there? Those many distances it will calculate. After calculating each of them, it will finally calculate. For example, k is equal to 1 means it will identify this one as the 1. Since it is a red color, it is also going to convert to red. Now, next, it is going to take k is equal to 2. Now here, this is the one and this is the one. Assume these are the 2 close points. For k is equal to 2, these are the 2 close points. After applying the KNN algorithm, that is 18 distances, these are the 2 least values. One is red, one is green. Now, which one it is going to select means which distance is low? Red color distance is low. So it is going to convert to red. Right? Now, k is equal to 3. 1, 2, 3. Automatically red is 2 and green is 1. No problem. If odd number is there means no problem. If k is equal to 4, now these are the 4 things are there. Now it is going to calculate the distance. Already distance 1, distance 2, distance 3, distance 4. For red colors, what are the distances are there? D1, D2. D1 plus D2 is for red. For green, D3 plus D4. It will calculate D3 plus D4, D1 plus D2. Out of these two, whichever is the least one, according to that, it will convert the color. Is that clear now? If it is odd number of, even number of data points are there, it is going to do in this way. Right? So here the k value is not fixed. If both distances are same, that is the thing, right? I know, just you'll ask the same question. But at least one student will ask the same question, minimum, guarantee. Okay. So if the distances are same, for example, this one, this one, this one, this one, and D1 plus D2, D3 plus D4, if the distances are same, if you convert to red also the answer is same. If you convert to green also answer is same. Then what is the difference? And if it has wrongly predicted means it will comes under misclassification automatically. If distances are also same and number of points are also same, everything is same, automatically machine will directly default, it will give us 0 as the default one. By default, it will select 0. Maybe correct or maybe wrong. If it is wrong answer means misclassification. Because the given data set is like that, then what I have to do? Okay. Is that clear? You are asking left eye, for you left eye is good or right eye is good. Then we can't say the answer, right? Both are equally good. No, you have to donate one miss. Anything is okay. Anything is same only for us. Right? So KNN classifier. So import the NumPy, Matplotlib and Seaborn, same warning, same thing. Now this time I'm going to work on the cancer dataset. Earlier diabetic dataset, now cancer dataset. Right? In tomorrow's class, loan dataset. Right? Now this is a cancer dataset where based on the 2 values, we have to predict whether there is a cancer present or not based on these two values. Now, df.info. Info is where we are having 3000 records are there. And if you do the scatter plot, if you apply the scatter plot, see x values and y values, hue is equal to output variable. I'm getting the value like this. This is the scatter plot. For example, there is a data point like this, some person. For example, there is a person. Person is with respect to this is 6.3 and this is 3.6. Assume. So just first you bring the value 6.3 versus 3.6. Now here is the data point. For this data point, just you have to identify how many orange color data points are there, how many blue data points are there. And according to that, we have to do. Right? Now, what I'm going to select is X and Y. That is, I'm going to drop the output variable. And in the output variable, I'm considering in the Y. Next, I'm going to apply the train test split. The same train test split I'm going to apply. Now, in KNN, 100% mandatory is scaling. You have to do the scaling. Scaling is mandatory. Mandatory. Mandatory means you have to do. Compulsorily you have to do. Otherwise, what happens? For example, you are having X1 and X2 records. Now, in the X1, you are considering with respect to like a car CC. Okay, you are predicting whether, let us take some example like predicting whether you will get a loan or not. Assume loan data set you are working. One of them is salary and one is age. Based on the age and salary, you have to predict whether the person will get a loan or not. This is the data set. Now, salary of a person is 40,000 per month, 50,000 per month, 38,000 per month, 20,000, 40,000, 45,000, 1,50,000. Something you are having like this. And the age of the person is 22, 23, 22, 22, 24, 26, 38. Something. Okay. Yes. Yes. No. Yes. No. Yes. No. Something you are having like this. This is the data set. Now, first you have to calculate the distance between these two. You ignore the output variable. Don't include the output variable. Now, how to calculate the distance between these two variables? Square root of 40,000 minus 50,000 whole square plus 22 minus 23 whole square. Now, this is 10,000 whole square plus 1 square. This 1 square will be impacted for this one. Huh? Simply it is ignored. So, one variable is suppressing the other variable. So, in this case, it is suppressing because this value is having less difference. Then it is saying that indirectly it is not having any importance. So, both the variables we have to give the same importance. Means what we have to do is we have to do the scaling. Now, if you do the scaling for this one, for example, I have divided with 10,000. 4, 5, 3.8, 2, 4, 4.5 and 15. Something you are having. 22, 23. Now, square root of 4 minus 5 whole square plus 22 minus 23 whole square. Both of them are equally important. 1 square plus 1 square, both are equally important. So, that is the reason 100% we have to do the scaling. If you don't do the scaling, means what happens means one variable will suppress the other variable. Whichever is having the higher magnitude, that variable will suppress the whichever is having the low value. So, that is the reason we have to do the scaling. Whatever the scaling you have applied for this column, the same scaling you have to apply for this column. For example, you are applying standard scalar, means for both of them you have to apply standard scalar. If you are applying min-max scalar, means for both of them you have to apply the min-max scalar. So generally for KNN algorithm, we'll apply the standard scalar. Okay, 99% of the algorithms will go with the standard scalar. Only 1 or 2 algorithms are there, special algorithms. For that only we are going to apply min-max scalar. Right? Now here I am going to apply the standard scalar and then I will apply the KNN algorithm. Now scaling. Scaling is mandatory. It is clear. Why scaling is mandatory? I have explained. Okay, scaling is done. Now scaling should be done before train test split or after train test split. This is the question. Scaling should always we have to done after the train test split. Scaling should be after train test split, not before to that. After train test split only we have to do the scaling. We should not do before. Why? Why? Reason behind that. The answer is called as data leakage. In the interview, they are going to ask you the question, what is meant by data leakage? Okay. In the interview, they'll ask you the question called as, what is data leakage? Data leakage means test data you are leaking before itself. Now, for example, you are applying the standard scalar. For this one only, you are applying the standard scalar. Assume for this data set, you are applying the standard scalar. This is enter x variable. No train test split you have done. Enter x. Now, x minus mu divided by sigma. Now, mu value is calculated including the test data or without x including the test data? Including the test data means you know the test data before itself. Huh? How the model knows before the test data. So, here the train values are getting impacted based on the text values. That is called as data leakage. So that is the reason we have to do the scaling only after the train test split. So here I am going to do the scaling that from sklearn.preprocessing import the standard scalar, and I am going to do the fit underscore transform on x train, fit underscore transform on the x test. Here fit underscore transform on x train. Here just I am doing the transform only. I am not going to fit. Here I am be calculating. For train data, I will calculate the things, and here I will be just transforming. On the test data, just we are applying the transform. We will never fit on the test data. Right? Now, once the scaling is done, now we are moving on to the KNN. So from sklearn.neighbors, import the k nearest neighbors classifier. We are going to import, and we are going to save in a model name. First step is called as import. Second one is called as save. Third one is called as fit on x train y train. Same thing. Whatever you have done here, instead of logistic regression, you are importing the KNN. That is the only difference. Same 3 steps. Right? Now, again, next, what you have done in the logistic regression, you have predicted on x train, predicted on the x test. Same thing. Predicted on x train, predicted on x test. Next, what you have done here, you have evaluated the train accuracy, test accuracy, and cross validation score. Same thing. Train accuracy, test accuracy, and cross validation score. Here I have done in the 4 different cells. Separately modeling I have done, prediction separate cell I have done, train accuracy, test accuracy separate cell, cross validation I have taken separate cell. 4 different cells I have taken. Here everything I have kept in the single cell. Nothing else. No sir, I am not interested. Means copy into the different cells as per your choice. If you write in the separate cell also, answer will be the same. If you write in the same cell also, answer will be the same. Right? So just I am going to apply this one. And after applying the KNN neighbors, I got the train accuracy of 94%, test accuracy of 92, and CV value of 92.66. Now from these 2, train accuracy and test accuracy, whether it is overfitted or underfitted, no, it is a good model. Now train accuracy, test accuracy is equal to this CV? Yes. Now we can consider. Now within this, I want to do the modifications, betterization. I want to do the betterization. Whenever you want to do the betterization, in your mind, 2 things you have to get. Better things you can get by, one is hyperparameter tuning. This will be applied for the model, betterizing the model. Second option is betterizing the data. That is future engineering. Future engineering is betterizing the data, doing the better, getting the better data, cleaning the data and working on the data. Model wise hyperparameter tuning. Now, if you observe in the KNN, by default, it is going to take the n neighbors is equal to 5. By default, the n value is equal to 5. The k value is equal to 5. And by default, it is going to select the Euclidean distance. It is not working on the Manhattan distance. P is equal to 2 means Euclidean distance. That is the meaning of P is equal to 2. Here the P value is equal to 2 is there, right? Now, if you drag this one, if you go here, n neighbors, default value is equal to 5. And similarly, if you drag down P value, default value is 2 because T is equal to 1 means this is equivalent to Manhattan distance. And Euclidean distance, P is equal to 2. By default, P is equal to 2. Default, it is applying the Manhattan Euclidean distance by default. And if you want to change, instead of going with the Manhattan distance, if you want to go with Euclidean or Euclidean to Manhattan. So here the two important hyperparameters are, one is K, second one is P. These are the two important hyperparameters in KNN. Sir, if I open the this one, shift tab in the help file, multiple parameters are there, right? Remaining parameters are also there. They are not that much of useful. If you want, you can try. Okay, they are not that much of useful. That is the reason I'm not explaining the remaining things. If you are interested, you can learn on your own. Which are the two important parameters? Means K and P. These are the two important hyperparameters. Now what I'm going to do is I'm applying the hyperparameter tuning. So in the hyperparameter tuning, whatever the grid set CV, first what we have to take? Estimator. The estimator is nothing but model name. That is KNN model. Param grid. Param grid is equal to n neighbors from 1 to 31. Similarly, P also 1 and 2. Now what happens? So it is going to take a list of 1 to 31. 1 to 31 means 1 to 30. So 30 different K values it is going to try, and P values of two different values. 30 into 2, total 60 different models it is going to apply. Out of all these 60 models, which model is the best one? I am going to identify. Same thing, whatever you have done in the lasso regression, ridge regression, and elastic net regression, the same thing. In elastic net regression, do you remember that alpha value and L1 ratio? Two things we have considered. Similarly, here also we are considering two things, that is n neighbors and P value. Just I am applying the grid size CV for these two. So total 60 models will be applied. After 60 models, now I got with respect to n neighbors is equal to 20 and P is equal to 2. This is the best it seems. Instead of 5, go with 20. Don't go with the 5. So now default model, write in the notes. Notes means not in your notes while doing this one. Okay, in your notes you have to write like this. Default KNN was given with train accuracy of 94.28%, test accuracy of 92.77%, CB of 92.66. This is the default KNN. Whatever the default values are there, that is K value is equal to 5, P value is equal to 2, default. Now you have done the hyperparameter tuning and you have identified KNN with K is equal to 20 and P is equal to 2. This is the best one. Default is K is equal to 5 is the default and P is equal to 2 is the default. Now after hyperparameter tuning, you have done this one. Now using this model, again you have to rebuild the model by using n neighbors is equal to 20 and P is equal to 2. And you have to fit on the X train, Y train. Again, you have to predict the X test and predict on the X train. And you have to do the evaluation, train accuracy, test accuracy, and CV. Now you have got this time, train is equal to 93.38. Test is equal to 94.46. And CV is equal to 93.66. Now out of these two models, which model is best? This model is best. Sir, train accuracy was reduced now. We are not focusing on train accuracy. We are not focusing on the train accuracy. Train accuracy is calculated only for checking whether it is a overfitted or underfitted only. For that purpose only we are calculating train accuracy. Only for one and only reason is to check overfitted or not. Otherwise, we no need to calculate the train accuracy. Only to check whether it is overfitted or not. Right? So here, in this case, it is not overfitted. It is a good one. And train accuracy is equal to this one. Again, it is a good. So it is a good model. In this case also, it is a good. Out of two goods, which good is best, miss? This one is better. Because test accuracy is high in this case. So this model is the KNN model. Now, using this model, you are predicting the confusion matrix and classification report. For which model is best model, that model only classification report and confusion matrix will be plotted. If it is a bad model, what is the use of confusion matrix? There is no use, right? Is that clear? So now within the KNN, I identified which is the best. So now you have what you have to do after the class. Now you have to practice as it is same way. Whatever we have done in the class, do the same thing, which is called as revision. Doing the revision, recollect whatever we have discussed in the class. Once again, you recollect and do slowly, step by step. Understand for each letter what is the meaning and for what purpose you are doing that one. Don't blindly don't do that one. Once do the revision. After doing the revision, now your work is to betterize the model. Within the KNN, how to get the better answer. Within the logistic, how to get the better answer. Now, in the logistic regression, now I have applied the, what is the data set? Diabetic data set. For this data set, you do the KNN. First, you do the logistic. Write the things. For logistic, what is the train, test, and CV. Write this one separate. Now within the, now start the KNN for the same diabetic. Within that, train test split also should be the same. You should not change the train test split also. Train test split also the same thing should be there. Test size should be the same and random state also should be the same. Whatever you have taken for logistic regression, the same thing should be given here also. Now within the KNN, identify with K is equal to 5 with P is equal to 2, which is the best one, and along with the hyperparameter tuning, which is the best one. And write in your notes the train, test, and CV for this, train, test, CV for this. Now out of all of them, so you are going to apply 3 different models for the diabetic data set. And out of these 3 ML algorithms, tell me which algorithm is best one. Is that clear? That is your assignment. If you feel assignment means assignment, homework means not homework, assignment one. Okay. This is not a simple one. It will take time, obviously. Right? For this diabetic data set only, logistic regression and KNN. Apply the KNN. Once this is completed, now take the cancer data set. Cancer data already KNN was completed. Now you apply the logistic on this and identify which is the best. Right? So please practice. And in tomorrow's class, we are going to discuss one more algorithm. Next algorithm, that is SVM, support vector missions. Sir, if you are working on the KNN for diabetic data set also, whenever you are applying the KNN, automatically you have to do the scaling. For whatever the data, you have to apply the scaling. 100% you have to do the scaling when you are working on the KNN algorithm. 100%. Sir, for logistic regression, if I apply the scaling, what happens? Check that one. Without scaling you do, with the scaling you do, and you only tell me tomorrow what is the difference. You identify that one. For logistic regression, do the scaling before take one Jupyter notebook. In that Jupyter notebook, do the scaling. Without scaling, do the logistic regression. Apply the logistic regression in another Jupyter notebook with scaling. Train test split, random state should be the same. Because you are considering the difference. You want to see the difference in scaling means remaining all the parameters should be constant. So train test split, test size should not change. Random state number should not change. Then only you can compare what is the difference of scaling. You just apply the scaling and you tell me what is the impact of scaling on the logistic regression. And tell me the same thing, impact of scaling on the KNN. Do separately. You tell me tomorrow the answer. If I apply scaling on logistic regression, what is the difference if I don't apply scaling? Because in logistic regression, I have not applied the scaling. I didn't apply the scaling and I have not shown you. In KNN, I have shown you particularly scaling. After train test split, I have applied the scaling. The reason why, you tell me tomorrow. Is that clear?